When you're configuring IP addressing for a set of devices, there are several issues that can arise as more devices are added to the same IP network. For example, if all the devices are in the same broadcast domain, broadcast traffic will grow dramatically as more devices are added to the network. As a result, additional broadcast traffic will consume host resources as the host now has to filter that additional broadcast traffic while searching for traffic that's specific to the host. The concept of subnetting is used to address these and other concerns related to having a large, flat network by logically dividing that network into smaller networks. And there really are many advantages of subnetting a network. For example, smaller networks are much easier to manage and easier to map to geographical or functional requirements. Smaller networks contain the broadcast traffic to the individual subnets, which reduces the overall amount of broadcast traffic, thereby improving performance. And of course, it's easier to apply network security measures at the interconnections between subnets than within a large single network. In a network with multiple smaller subnets, connectivity between those subnets is provided by using a router. And the IP addressing that's used in a large single network needs to be modified to accommodate the requirements of segmentation. By introducing a subnet mask, we can identify the network significant portion of an IP address. Now, the network significant portion of an IP address is called the network address, and it simply identifies the network that the host device is on, and it also defines every subnetwork. When you express an IPv4 network address, you add a prefix link to the network address, which is the number of bits in the address that gives the network portion. The entity that's used to specify the network portion of the IPv4 address to the network devices is called the subnet mask. The subnet mask is used by end systems to identify the destination IP address as either local or remote. Routers use the subnet mask to help determine the path to the network. A subnet mask defines the number of bits that represent the network and the subnet part of the address. Just like the IPv4 address, the subnet mask is made up of 32 bits, and it uses ones and zeros to indicate the bits of the address that are the network bits and those that are the host bits. You express the subnet mask in the same dotted decimal format as the IPv4 address, and it's configured on a host with the IPv4 address to define the network portion of that address. The networks will not always assign the same prefix. Depending on the number of hosts on the network, the assigned prefix may be different. Having a different prefix number changes the host range and the broadcast address for each network. Variable length subnet masking, or VLSM, refers to the concept that subnets can be created with different subnet mask lengths. One of the benefits of VLSM is that the IP addresses can be more efficiently allocated to each subnet. For example, a point-to-point connection only needs 2 IP addresses, one for each of the 2 devices. Therefore, creating a /30 subnet, which creates subnets with only 2 hosts, makes a lot more sense than using a /24 subnet, where 252 of the 254 available IP addresses would never be used. VLSM allows for more hierarchical levels within an address plan. This enables you to take a major network such as a Class A, Class B, or Class C network and divide that network into subnetworks. In other words, VLSM allows more than one subnet mask within a major network and allows you to subnet previously subnetted addresses.